Welcome to PreMath. In this video, we have got these two identical circles fully inscribed in a rectangle CDEF, as you can see in this diagram, such that DF is the diagonal of this rectangle, and P and Q are the points of tangency, and moreover A and B are the centers of these identical circles. And furthermore, this side length of this rectangle CF is 21 units, whereas this side length EF is 28, and M, N, H and G are the points of tangency as well. And now our task is to find the distance between these two centers A and B. In other words, we need to find the length AB. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We can see that we are dealing with this rectangle CDEF. So therefore, this side length EF is going to be equal to this side length CD. If this side length is 28, this has got to be 28 as well. And here's our next step. Let's focus on this right triangle CDF, whose side lengths are 21 and 28. And now we are going to calculate its longest leg DF. And now let's recall the Pythagorean triplets 3, 4 and 5. And if I multiply all these numbers by 7 across the board, then our new triplets is going to become 3 times 7 is going to give us 21, 4 times 7 is going to give us 28, and 5 times 7 is going to give us 35. And since our side lengths are 21 and 28, so therefore this longest leg DF is going to be 35 units. And here's our next step. Let's go ahead and connect this center A with these points of tangency H and G. As you can see, I have connected A and G and A and H as well. And now we can see that this AG and AH are the radii of this circle. Let me call this radius lowercase r, and this is going to be radius lowercase r as well. And now let's recall the circle theorem. According to this theorem, the angle between the radius and the tangent will always be 90 degrees, as you can see in this given diagram. Here we got this radius and this is our tangent line. So no wonder this angle is going to be 90 degrees. So therefore, in our case, these two angles, this angle and this angle, are going to be 90 degrees each, since these are our radii and these are our tangent lines. And now let's make an observation. We can see that this CHAG is square, where this side length is going to be equal to this side length, and this side length is going to be this side length. If this is r, this is going to be r, and this is going to be lowercase r as well. And now let's make an observation. We can see that this whole CD length is 28, and this tiny length CH is lowercase r. So therefore, this segment DH is going to be 28 minus r. And likewise, this side length CF is 21. This side length CG is lowercase r. So therefore, this segment FG is going to be 21 minus r. And now let's recall the two tangent theorem. According to this theorem, if two tangent segments are drawn to one circle from the same external point, then they are congruent, as you can see in this given diagram. So therefore, this segment OA is going to be equal to this segment OB. Now let's revert our attention back to this problem. We can see that this tangent GF is going to be equal to this tangent FP. So therefore, if this segment is 21 minus r, then this segment is going to be 21 minus r as well. And likewise, this segment, this tangent DH is going to be equal to this tangent BD. If this segment is 28 minus R, then this segment is going to be 28 minus R as well. And now let's focus on this whole diagonal DF, that is the sum of these two segments, 21 minus R and 28 minus R. And we also know that this whole diagonal is equal to 35. So therefore, let me go ahead and add the segments 21 minus R plus 28 minus R is going to be equal to 35. Let's go ahead and combine the like terms. So we are going to get 49 minus 2R equals to 35. Let's go ahead and subtract 49 from both sides. This is gone. So therefore we got negative 2 times R equal to negative 14. Let's go ahead and divide both sides by negative 2. So therefore our radius R turns out to be 7 units. And here's our next step. This time I have connected this center B of this another circle with this point of tangency M. So therefore this is going to be our radius R, and this is going to be our radius R as well, since these two circles are identical. And furthermore, this angle is going to be 90 degrees according to circle theorem, since this is our radius and this is our tangent line. And in this next step, I have extended this line GA all the way to T. And as a matter of fact, we got this right triangle ABT. And now let's make an observation. We can see that this length is lowercase r. So therefore, this length is going to be lowercase r, since this is the radius. And now we know that our radius value is 7 units, this r value is 7 units, and this radius r value is 7 units as well. And now let's make an observation. We can see that this segment HL is going to be 28 minus 7 and then minus 7 once again. 28 minus 7 is going to give us 14 units. If this segment is 14 units, then this another segment AT is going to be 14 units long as well. And here's our next step. Let's focus on this right triangle ABT, whose side lengths are 14, 7. And now we are going to calculate this length AB. So therefore we are going to apply the Pythagorean theorem. And here's our Pythagorean theorem: a square plus b square equal to c square. Let me call this longest leg as our side C. I'm going to call this side lowercase a and this side lowercase b. So let's go ahead and fill in the blanks in this Pythagorean formula. A in our case 14 whole square, b is 7 whole square equal to c square. Let's go ahead and simplify. That is going to give us 196 plus 49 equal to c square. So therefore c square turns out to be 245. Let's go ahead and undo this square by taking a square root on both sides. So therefore our side length C turns out to be equal to, and now we can see the square root of 245. I have copied it down over here, and if we simplify, this is going to be equal to 7 times square root of 5. So therefore our C length is going to be 7 times square root of 5 units. So therefore our this AB length turns out to be 7 times square root of 5 units. So thus our AB length turns out to be 7 times square root of 5 units, and that is going to be approximately equal to 15.65 units. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.